Can't spell solving polynomials without OVO. Here we go, last lesson of Unit 2. Our learning goals, we're going to solve polynomials using a variety of strategies. Really, this is just going to take what we've already done and just add one little thing to it. Our first example, we are going to solve each one of these. And whenever you see solve, your mind has to go to, I am finding my zeros. How do you get to zeros? Factored form, which means you have to factor. That should be your thought process. These three, well, two of these three are already factored for you. A is pretty easy. What makes each bracket 0? X equals -3, 1, and -4. Done. B, same idea. What's going to make it equal to 0? X equals 0, 1. And we do have to factor this end part first. That's a difference of squares, x plus 3, x minus 3. Which means we're going to have zeros or solutions at plus or minus 3. C, that's not factored form, but we only have two terms, so it's relatively easy. Set it equal to 0. Bring that -20 over, it becomes +20. Now we know how to get rid of a squared. We square root. How do you get rid of a cubed? Well, you cube root. And cube root 20 is not a nice number, so we're just going to leave it at that. Cube root 20 is our solution. So nice easy examples, get us warmed up. Our next example, still solving, still real solutions. And the goal of this is just to show you or remind you of some things. But at the end of the day, you do whatever comes to mind and whatever you are comfortable with. One possible way to solve this is to distribute. So maybe I'll write that. So maybe we'll write A. One possible way is to expand, collect like terms, set it equal to 0, and then factor. Which, since we're going to end up with a cubic, we're probably going to have to use factor theorem and synthetic division, possibly. So if that's your comfort zone, if that's what your gut feeling is for a test question, do it. What I'm going to show you is, since on the left we're multiplying and on the right there's just one thing going on there, x minus 3, you could just divide both sides by x minus 3. And if you did that, let's see what happens. And these only work in certain instances, so I'm showing you very specific examples. Well, those two things would cancel out. Those two things would cancel out. And by cancel out, I just mean anything divided by itself is 1. So you're just left with 4x squared equals 1. Divide both sides by 4. X squared equals 1/4. Now square root both sides, right? And whenever you take the square root, don't forget it's plus or minus the root of a quarter, which is plus or minus 1/2. So this means that if you were to do expand, collect like terms that equal to 0 and factor, that means that f of 0.5 or f of negative 0.5 would have given you 0 if you were using the factor theorem, which means two of your factors would have been 2x plus 1 and 2x minus 1. B. So again, your default might be factor theorem, which that's fine. So you could use factor theorem, synthetic division, and so on. What I'm going to do is, this only works in specific examples, is I'm going to factor by grouping. And I've already laid them out in the order that they should be for grouping. So we're going to group them in groups of 2. And again, this does not work for every single question. When you factor by grouping, that means that you common factor, and in this case, groups of 2. So what can I common factor out of those first 2 terms? A 4x squared, which leaves me with x minus 3. And the second 2 terms, all you can common factor out is a negative 1, which leaves you with x minus 3. If you factored correctly, grouping, that means that what you have in brackets should be the same. It is. So that means this question either, it means we did it right, but it also means that what we did with the factoring by grouping is actually a possibility for this question. That's like common factoring again. What's common to both of those terms? The x minus 3, so you common factor that out, and that leaves you with 4x squared minus 1. Now we're still not done because that's a difference of squares. 2x plus 1, 2x minus 1. Now we're ready for our solutions. Don't forget, set that equal to 0, x equals 3, and then plus or minus 1/2. If you did do factor theorem, you would get to the exact same conclusion. And again, I can't stress this enough. I'm just trying to remind you of some different strategies that are at your fingertips that you would have seen in grade 10, maybe grade 11. Again, if this is like blowing your mind, you stick to what you've been practicing for the past couple lessons, which might have been factor theorem. Example number 3, we're still solving, but this time for a specific value. So I'm saying for you to factor or to solve for this, I want to know what's the value of x when f of x is 10. So your first step is going to be to set this whole thing equal to 10. So 10 equals x cubed plus 2x squared minus 14x plus 22. We're going to set that equal to 0 by bringing our 10 over. It's going to become negative 10. So 0 equals x cubed plus 2x squared minus 14x. 22 minus 10 is 12. You could try to arrange these to factor by grouping. I don't think it's going to work out. And yeah, if we rearrange that, I don't think it's going to work out factoring by grouping. So in this case, we are going to have to go to factor theorem. So you want to test values, factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so on. So by all means, pause it, try those, see if you can come up with one of them to equal 0. I'm pretty sure f of 2 works. So f of 2 equals 0. Now, since this is asking you to solve, you technically don't need to write this in factored form. You technically don't have to write therefore x minus 2 as a factor. If you want to, you can, but you've already come up with one solution. It's 2. So now let's go to everyone's favorite, I'm guessing, synthetic. Our coefficients, 1, 2, negative 14, and 12. Bring that down, multiply, add, multiply, add, multiply, add. We know it works, got 0 remainder. So this equals x squared plus 4x minus 6. Now you'd have to factor that. Two numbers that multiply to negative 6 and add to 4. I can't think of any. We want that to be 0, don't forget. Doesn't mean it's not factorable necessarily. What it does mean, though, is to get solutions, you're going to have to go to your trusted formula from grade 10 and 11, the quadratic formula. So we are going to quadratic formula this. So x equals, in case you've forgotten, I will write the formula for you. Negative b plus or minus the root of b squared minus 4ac all over 2a. Do not forget a, b, c. So negative 4 plus or minus 4 squared minus 4 times 1 times negative 6 all over 2 times 1. Doing some very quick math, we should get negative 4 plus or minus 16 plus 24 is root 40 over 2. And then going back to your favorite unit in grade 11, rationals and radicals, we can actually break up that root 40. So remember that root 40 can be broken up into root 4 times root 10. And the reason why you want to do that is because the root of 4 is 2. So x equals negative 4 plus 2 root 20, 2 root 10. All over 2. And we can simplify that. Everything divides by 2, so that gives me negative 2 plus root 10. And then negative 4 minus 2 root 10 over 2. Negative 2 minus root 10. So our solutions are these two. And don't forget we got this. So, and also x equals 2. And those are our 3 solutions. X equals 2, and those two. X equals negative 2 plus root 10, negative 2 minus root 10. If you're thinking, can I round that to a decimal place? Grade 12 advanced functions, if we can simplify our radicals, we are going to and leave it like that as opposed to decimals. With that being said, if it ends up being a nice decimal like 0.5, I will allow it, but in most instances, it is not going to work out to a nice number like that. So we're going to keep it like that. Okay, we're going to challenge ourselves. We are the cream of the crop students. So in summary, to solve, I kind of already made this little flow chart for you, but to solve, that means that you want to find your zeros, which means set it equal to 0. You need the factored form, which means you have to factor. Or if it's not factorable, so If it's not factorable, quadratic formula. If not factorable. Or maybe the numbers are too big, or maybe you just don't remember how to factor. And we've learned how to factor higher order polynomials this unit. So there's your work. Just so you are aware, this kind of ties in with the unit that we're doing together that I'm teaching you. In the textbook, they treat it as a part of the next unit. So in case you are doing the test review, you're not going to find any questions that say solve in it because what I've just taught you, the textbook treats it like it's a different chapter or in a different chapter. So just do these as kind of like your practice plus your test review for this lesson. Even though I showed you different things on how to factor, like I mentioned, it's basically just taking everything you've learned and setting it equal to 0 and stating your solutions, which you've kind of already been doing, right? Whenever you find f of some number, set it equal to 0. So nothing earth-shattering. I just showed you some different things. At the end of the day, if you don't like it, doesn't work for you, the question perhaps doesn't work out the way these ones did, your go-to factor theorem, synthetic division. So that's the end of Unit 2. Make sure tomorrow morning you log in during the time limit to start your test. The earlier the better for you, then you can get more of a head start on the next unit, which you will have that test on Friday afternoon. Do not forget. And just another quick, gentle reminder, please make sure that your solutions are in order of your test version. If you don't know how to do a question, leave yourself some space and write number 2. Leave yourself some space, number 3. If you're someone that likes to do graphing on graph paper, maybe cut it out and tape it to your solution when you go take a picture of it, or just place it over top of that space when you go to take a picture of it, or maybe just leave me a little note that says, here's the work, I did my graph at the end. So that way I know when I go to mark it, it's not like, hey, where's your graph? And I only give you 2 out of 4. And then I find your graph later on and I'm like, oh, I got to go back and change it. Just makes life easier for me, but you should definitely make sure that your questions are done in order. I will post another how-to video. Most of you kind of figured out the PDF, but I'll post another how-to video for those of you that are still missing out on that easy bonus mark. Maybe you don't want that easy bonus mark, but I will. It's literally going to be 90 seconds long, the video. I made it from my other class. It's pretty foolproof. If you don't know what to do after watching it, then you're just going to have to submit individual pictures.